All right, so let's go over the warm-up 8.3, the factoring practice. You'll see on the left there's one type of problem setup that just has some variables and numbers. And on the right there's a similar setup for a problem that now uses our trig equations. So let's just practice factoring with regular equations, and then we'll do some factoring with trig equations inside. So on the first problem, what you should notice is that both of these terms, these are two terms, have something in common. They both have x squared in common. So we're going to factor that out, or divide it out of each term. So I'm going to be left with 1 for my first term, because if I divide x squared by x squared, I get 1. And then if I divide that second term by x squared, I get y squared. And then we've got something similar over here to the right, where we again have two terms. The first one is sine squared theta, and the second one is sine squared theta cosine squared theta. So what we're looking for is what they have in common. And what they have in common is that sine squared theta. So we're going to take that out. Sine squared theta and then that leaves us, there's always going to be two terms left over in the parentheses. However many terms we started with, or how many we're going to end up with in the parentheses. The difference is this becomes a 1 now. It doesn't disappear. And then we have 1 minus cosine squared theta. All right, for the second one, same idea, but our GCF is x squared for both of these. X squared. And then that becomes 1 plus y squared. If you're ever not sure if you factored it right, go ahead and distribute back in and make sure that it equals what we started with. So on the second expression, we've got one term and another term. And just identify your GCF is cosine squared. So we're going to take that out. Cosine squared theta. And that's going to leave us with 1 plus tangent squared theta. Again, if you're not sure if you did it right, distribute back in and see if we get our original expression. For number 3, this is a little bit different. We don't have a GCF. But when you see two terms and a subtraction sign in between them, and those values, each term is a perfect square, this is called a difference of squares. Difference of squares. And we can factor a difference of squares quite easily. So when we have a difference of squares, we have something like a squared minus b squared. It always factors like this. A minus b times a plus b. And what happens is when you FOIL this out, your outer and inner terms end up canceling out. So if I want to factor x to the 4th minus 1, then what I need to do is take x to the 4th and write that as x squared and x squared. 1 becomes 1 and 1. One of these gets a plus, one of these gets a minus. Now technically I see another difference of squares right here. So I'm going to factor that further. So I'm going to bring down the x squared plus 1. That's not a difference of squares, that's a sum, so we can't use the difference of squares factoring. But x squared minus 1 can be written with two parentheses, and now that's just x and x. 1 and 1, plus 1 minus 1, doesn't matter what order. And that's fully factored. So let's apply that to tangent here. We've got tangent to the 4th of theta minus 1. So I'm going to start with tangent squared theta and tangent squared theta. And then we do a plus 1 and a minus 1. Now we could factor this one further, but what you're going to see, and with our trig identities, it's not usually helpful to factor this any further, but if we did want to, it would look like this. Tangent squared theta plus 1, that's our original. And then this would be tangent theta minus 1, tangent theta plus 1. All right, number 4 is also a difference of squares. Pretty straightforward. X squared minus 1, x minus 1, x plus 1. For cosine squared minus 1 is the same thing. That's like our x squared. So instead of x and x, we'll write cosine theta minus 1 plus 1. All right, so number 3 and 4 were examples of differences of squares. If we look at number 5 and number 6, those look like examples of our classic quadratic equations that we use to factor. So when I look at the first problem for number 5, I see we have an a value of 2. And what we're going to do is set up 2 sets of parentheses here. One of them starts with a 2x and the other starts with an x because we want them to multiply to 2x squared. And then we choose the numbers that go in the second position in those binomials by looking at what multiplies to make that 1. Well, the only thing that multiplies to make 1 is 1 and 1. Now all we have to do is make sure that we get these to add up to negative x. So when I do the outer terms, I get 2x. And when I do the inner terms, I get x. Oh, I think our signs should be different on this. Let's go ahead and change this. Let's take this problem and rewrite it. 2x squared minus x minus 1. All right, so we're not going to deal with this plus sign. That's going to be a minus sign. So we want things that multiply to 1. That's 1 and 1. And we don't know which sign is going to be the negative. But like I said, the outside terms multiply to 2x. The inside terms multiply to x. To get these to add up to negative x, I need this one to be negative and this one to be positive. So I put a minus here and a plus here. All right, so that's my fully factored form. The work below is just confirming that we actually add up to that middle term. When you look at number 5, let's go ahead and fix that. This should also be a minus sign and not a plus sign. Now, if you notice, the sine theta just really replaces the x squared. So we're going to have the same setup, and we're going to say 2 sine theta. That's kind of like 2x in the last problem. And then sine theta, that's like x in the last problem. We know these have to be 1. And then again, to multiply, I've got 2 sine theta, and then I've got sine of theta. If I want these to add up to negative sine theta, this is the minus, this is the plus. And this is our fully factored form. Okay, last example. One more quadratic. We got x squared plus 2x plus 1. So when I go to factor this, start with x and x. And then that covers us for our a term. For our c term, times 1, 1 and 1. And in order for these all to be positives, it's got to be plus 1 and plus 1. You can just check your outer terms and inner terms to make sure they actually add up to your middle term. All right, when you look at the tangent squared theta plus 2 tangent theta plus 1, if we go to factor that, some people like to just rewrite it as like a squared plus 2a plus 1 and think about a equaling the tangent of theta. Sometimes not writing all the letters as you're factoring helps a little bit. So then you go, okay, that's a plus 1, and then you go and substitute the tangent theta in. Tangent theta plus 1, tangent theta plus 1. So that's fully factored. And we just wanted to get a quick little refresher of some of our factoring in, because we're going to take the skills we've used before in factoring, and we're going to apply them now to trig functions. So you should be ready to go for your notes.